the weather. We're all impacted by it, and to some extent, we also like to talk about it. But today, I will be looking at a way of receiving information about it using the radio. Hello, and welcome back. Today, I want to talk about my experiences receiving weather faxes, which are faxes about the weather. It's more interesting than it sounds. Weather fax is a form of radio-based image transmission where the object of the transmissions are weather-related charts. The service was started sometimes in the 50s and is still available to some extent even today. The transmission is done from ground-based stations located all over the world, and the typical transmission frequency is somewhere in the HF bands. While there are modern internet and satellite-based equivalents which provide better quality and more robust transmission, the weather fax is still kept mainly as a secondary or emergency service, which would be available if other methods fail. While there are multiple resources for this, one of the best overviews of stations I found is this one provided by the US Department of Commerce National Oceanic and Atmospheric Administration. So this is a document that lists the various stations distributed over the various continents, and if you look into the details of these, you will find the transmission frequencies, the transmission power, encoding type, and a timetable of the information that will be transmitted. So at what time and what exactly will be displayed. Just keep in mind that the time is UTC time, so a bit of conversion to local time will be needed if you want to receive any of these. Another good resource I found is the weatherfax.com website, which has a nice cartographic overview of the stations on a world map. So it will be easier for you to figure out which station is closest in your case in case you want to actually receive something. Now, clicking on any of these dots will highlight the station, so the exact transmission frequencies, and the timetable, so what is being transmitted and when, and for some of these, you will also get an example. So just to see what sort of a map you should be receiving. Since the stations have quite strong emissions, most are driven in the kilowatt range, receiving them is not that difficult, at least the ones located in your relative vicinity, so a couple thousand kilometers. Multiple reception setups will work, so next let me show you the gear that I used to receive such signals. From a setup point of view, I used an SDR connected to a PC, and since the signal is located in the HF bands, I used an active loop antenna with a bias T to pick things up. To improve the setup, extra amplifiers can be useful, as well as some filters to reject the AM or FM bands. For the software part, well, you need the control software of the SDR and output the audio, and commonly decoding is done using some dedicated WeatherFax software. In my case, I use the Black Cat HF program, which has a free version. And to link the two, some form of virtual audio cable is needed. It is, however, possible to put the decoder as a plugin into the SDR program, but I couldn't be bothered to get that working. Anyway, the signal itself is amplitude modulation, upper sideband, with a bandwidth of 2.8 kHz. Based on the documentation, you either get the center frequency, from which you need to subtract 1.4 kHz, or you get the actual frequency, to which you need to set your receiver. This is something to take care of to get good results. Usually you want to keep any automatic volume gain settings low, and for the decoder to work well, I noticed that keeping the volume low improves signal-to-noise ratio, since that reduces distortion. So, all things assembled, connected, and installed, what can you actually receive? Or at least, what was I able to pick up? Well, I tried with 3 stations. First, the United Kingdom-based one seems to be offline, so there's nothing there. But the ones that I did successfully receive was the German Hamburg-based station and the Greek Athens-based one. Since the signal transmission is ionospheric propagation based, the signal will never be perfectly clear. You will get various fading effects. This will definitely be visible since a single complete transmission can take up to 20 minutes. But the end result is still relatively readable. Now, you can record the audio separately and work with that at a later time, but I found it far more convenient to just directly plug it into the decoder and make live adjustments as you need to get the best reception. Anyway, once the setup is fine-tuned, you can then wait for the next transmission and, well, let the setup record and save automatically. So here are some of the maps I managed to get. These are from the Germany-based Hamburg transmitter, and these are some of the cleanest images I managed to obtain. I guess the proximity and high power is the main reason for that. Now, other than those, I also managed to get a few maps from the Athens, Greece-based transmitter, but these are not as clean. I guess a better antenna and maybe some extra filtering would manage to improve on things. So, other than a love of meteorology, why should you bother with doing any of these? Well, I found that receiving these signals is far easier than other radio-based image transmissions like SSTV. The transmitter location is fixed and the transmissions occur quite often, so you have a lot of chances to get good results. And also, it's quite interesting to build and fine-tune such a setup. And the experience you get will help you in far more complex endeavors. So, with that said, hope you enjoyed this video, and if so, there are more similar videos on my channel that you might want to check out. And if you want to be up to date with my latest releases, also consider subscribing. See you next time. Bye bye.